How can you rewrite this without a radical in denominator? So we're going to have to rationalize. But when it's a binomial, it's a little different than when it's just a monomial that's a radical. In order to clear out what's going on here, you need to multiply it by its conjugate. So let's take a look at the solution here. So 2 plus root 5 has a conjugate of 2 minus root 5. When you multiply them together, it will clear out the radical. And then the numerator is going to be what it's going to be. And that's okay. Yes, and you end up with -1 as your denominator. 4 minus 5 is -1. And then when that's the case, you don't need to leave a negative in the denominator. You can just divide both by -1, essentially. And you end up with root 5 minus 2. So what is the reduced radical form of each expression for these two try-it questions? So why don't you give these a try and then come back and check. But again, essentially what you're going to do is multiply numerator and denominator by the conjugate of the denominator. So give them a try, and then after you pause it, give them a try and come back and check. First, well, example A in purple there, conjugate of the denominator is 2 plus square root 3. So multiply that numerator and denominator. Numerator works out to be 10 minus, and notice how I did just change the order so they go numerically. For the radicands, it does not matter, though. There's not a rule like that that you have to follow. I just do that. Anyway, you end up with 10 minus 2 root 2 plus 5 root 3 minus square root 6 over 1, so it just ends up being the numerator. Down here, the conjugate of 1 minus square root x is 1 plus square root of x. When you multiply and simplify, you end up with negative 4x minus 4x root x over 1 minus x. That's it. So give the exit ticket a try, and then we'll go over that tomorrow. Let me know if you have any questions.